All right. Well, welcome everybody back. We're going to be working on the lightsaber some more today. And yeah, that's about it. I think today's plan is just to, we got to make our own model for the teensy. And we have to make a model for the USB-C port. The teensy should be a little easier just because the square shapes are fairly easy to work with. The USB-C port's going to be a little trickier, so we'll see how far along into that we get. But yeah, we got to make footprints and models for both of those. So let's get started. I'll turn the music back on. All right. Dogecoin value went up today, so if you get one of these bounties, they're worth more than they were yesterday. All right, so we're going to go... I'm going to work based off of this. I kind of want to add something... I think I want to add something to this. Yeah, let me... Let's up and hold on. I need something else too. All right, there we go. I think the stream quality is looking good. Just trying to fix a couple things. There we go. Okay. Got to make sure I see any comments that come through. All right, let's pull up the appropriate things. And then I'm going to make a screenshot of this that I can reference. All right, excellent. Move that off to the side. Okay, so we can leave this one here for the time being so that we know how everything's wired up. But then we will need to do that again here in a second. Let's go part. Teensy 4.1. What do we got? This one. This one doesn't have any symbols or models, but it's exactly what we need. So create new component. So this is how this worked last time, is I made a new component from it. I don't know if I make models and symbols like this, if they show up like in the library for everybody. I want to add, can I add an existing symbol? That would save me a ton of work. Really? Neither of these are... Oh, wait. This one. I think this is the one that I need. What is different? Did they just notate something? This is the latest one that somebody made. Not this one. Does this have anything interesting in it? This has a few extra things. All right, this is probably the one we want to use. Okay. And I want to edit it. And I'm gonna, so what we're gonna do here is add 2 more pins, which are for the USB port that's you program the teensy with. There's a couple pads underneath it that you can hit with like pogo pins or something. And I want to add those here because I'm gonna have to do that in my circuit. So let's do that. Pin. All right. I wish I knew like a keyboard shortcut for rotating this. There may by design not be one, just because, oh, that was the wrong way. They want this to be not easy for like big designs, because it's a free software. But their paid software costs so much money. Okay. Which one of these is the designator and which one is... Okay. Alright, so we want the name, USB in D plus. And then USB in D minus. Plus. Oh, shoot. Why is there not an oh, there is an undo. It's just really slow. All right. That looks good. And then the rest of this is going to be... Oh man, this is going to be such a nightmare to try and do all this. Yep. Just trying to think through this all. Okay, I think everything is on here that we need. Now I need to pull up the actual schematic from this. Oh, perfect, and it's listed. So here's the layout for this. Top and from the other side. Yeah, it's flipped. Okay. So these are all the little vias that we need to do. I don't know if we need to do this little header. What is that for? It's somewhere in here. Here it is. Ethernet. Okay, I don't think we're doing that one. Let me check our bill of materials here, but I'm pretty sure we ignored that. There's no like LED or anything. Yep, okay. So we don't need to do that little header, which is good because it's a slightly different size than the rest. But we need to do basically everything else. So all of these pins on both sides, all of these pins here, and which I need to double check, but I'm pretty sure they're all, yeah, they're all 2.54 millimeters apart, or 10th inch spacing. We'll have to do that one too. I don't remember which one that little via is. And then we need to put 2 here. Interesting on the spacing. All right, so this is going to take a while, which is fine. I kind of figured that I wasn't even sure I'd get to the USB-C port tonight. I figured this would take so long that I would pretty much doing all this all night. All right. All right, I think it's good. You know, I might be able to use the existing model from the one we were already using. And that's kind of okay. I might be able to use the existing model and just modify it. Let's go ahead and modify this. Save that. Existing footprint. Let's see what we can come up with. Anything? Maybe it's just running really slow tonight. Oh, there it goes. Yeah, it's a complex part, so it's taking a little while. Okay, that has almost everything. It doesn't have that little via that was right there. That's okay. If we need it, we can add it. What's the 3D look like? Okay, yeah, it was too high off the board. I think that was the big problem. I might be able to use this and save me some time if I just edit it. Because it already has most everything laid out exactly the way we need it to be. There's the one via here, I think. So I need to figure out what that is. Looking. Going through this huge article. I don't know what that is. I don't think it's used for anything. It might be a duplicate ground or something. Okay. Well, if it's not listed anywhere on here, then I haven't planned to use it yet, so it's probably not that big of a deal to not have it. Let me make sure all this is right. 5-volt ground, 3-volt. Okay, yeah. So this orientation looks correct. All right, and then this is circuit board, top, rotation, standoff height, 315.961. Okay, hold on. Let's go to metric. Try this again. Standoff height is 8 millimeters. Okay, so that's the part that I probably just got to change that. Type is generic. So it's a model that somebody uploaded. Oh, shoot. I thought this was going to take a long time tonight, but this might actually be really easy and fast. Because it looks like most of the work is done for us. All right. This model looks amazing too. Look at it. It's even got the SD card and all that. So the problem is it's too high off of these vias here. So we need to bring it down some. Excuse me. All right, well, I gotta be honest. I wasn't really looking forward to designing this whole thing myself, so if I can just modify this one, that is gonna save me a ton of time. And then we'll have our control board done and we can start wiring up even more stuff. Oh, that's actually really exciting. Okay. So we need to add vias for the pogo pins. So we can just use the same size and just position them correctly. And I think that would be best. Yeah, I think that would be best. So let's go back to the 2D version. Oops. All right. And then pad, copy, paste, one there, one there. Okay. So the spacing is actually done from this side because of the way the model, it's upside down, the graphic I'm looking at here. So it's 0.51 down from this height. Properties. And then since I'm not going to need this old graphic, I'm just going to copy this real quick so I remember the numbers. Okay. So it's over 6.35. So subtract 6.35 from the x. So I'm going to need a calculator. I could probably do this math in my head, but I really don't want to. All right, so 7.62 minus 6.35 is 1.27. Okay, so it looks like it's centered vertically, so that makes this a little easier, actually. 0.27. Oh, no, wait. We don't want to do that one. We want to change this one. .27. And this one will be negative 1.27. All right, and then height. This is the trickier one. It's down 0.51 from this one. So 29.21 minus 0.51 equals 28.7. Oops. 28.7 millimeters. All right, now I just need to rename them based on our designators over here. So it was in D plus and in D minus, and I gotta get them right, which is which, or I'm gonna really regret, be really disappointed. Looking for it. Okay. D minus, D plus. So D minus is on the right side. D plus is on the left side. D minus is on the right side. Oh no. Whoops. So this one's D+. All right. Okay. That should be good. Save that. They don't have the pads marked here, but I think that's correct. Yep, looks correct. All right, cool. Oh, so now we need to figure out, okay, we need to adjust the model. So I need to look at some headers that I'm gonna use. There's headers. I don't need anything fancy. Here we go. These are pretty standard. I'm going to use these. These are from a company called Samtech, which makes this stuff, and it's really expensive, the stuff that they make, but they are really good and standardized. I may not use these ones in particular, but I'll use something similar. So the reason I picked them is because it's all standardized. They should have a pretty good data sheet. Here we go. Yep, you can buy all kinds of different things of this size. What I want to know is the thickness of the actual header, the plastic piece. Looks like they don't actually tell you. You just have to subtract out the difference of the different lengths. All right, fine. Let's just pick one. So A minus B minus C of any given one is effectively what it is. So 8.51 minus 3.30 minus 2.67. And that number should, I think, should come out the same for all of them. We can try it a few times, though. All right. 8.51 minus 3.30 minus 2.67. Yep, 2.54. That makes sense. 1/10 of an inch. Let's see. 7.62 minus 2.41 minus 2.67. Yes, also 2. Okay, so I think those, yeah, that's good. So the thickness is just 1/10 of an inch, 2.54 millimeters. So we'll change this model because its standoff is 8 millimeters. Change it to 2.54. Okay, and then if we go to the 3D, we'll see that it's much lower now. Yep, much closer to these vias. And it looks like all of the components are still looking far enough off. Nothing is going to touch the board. So that's good. Okay. I do want to go ahead and put a model in for... Oh, you know what? I don't know where the reference for this model is, because this does look really tall. But how I can figure this out, I want to put in the block where all these headers are going to be. the actual plastic part, so that I know how big that's going to be too. So that'll let me know if it's close or not. All right, let's go back to it. And I gotta somehow make this shape. What is the grid here? 1.27. Oh, that's smart. I think. So the way it looks like it's been done is it makes everything, the grid has been done to make it easy to tell how far it goes. This might be the easiest I've been able to draw one of these 3D bodies yet. All right, so go here, go here, go all the way. Oh, wait. Nope, it's not far enough over. Dang it. Let's try again. Go here, go here. Scroll down to here, go there, go there. There we go. Okay, there we go. Got a 3D body. Looks correct. Properties. H. Let's do header. Let's do H row. Header row 1. Extruded overall height 0.254 millimeters. Standoff looks correct. And let's make it black. Okay. This will let us know if our models are in the correct spot. That doesn't feel right. Hold on. That looks really small, actually. It should be 2.54. It was way too small. All right. Now let's check it out. Oh, that's perfect, actually. So yeah, the teensy's the correct height off the board. Perfect. All right, so we just need to run through and do that for all of these different sections. And then we'll have our teensy model finished. I just realized that how close some of these are. There is literally no room for error here. Like, I'm going to have a hard time squeezing this in. Any variation in the plastic at all is going to make it basically impossible. All right, let's do one on this side. I'm glad I decided to do this because not only was it easier, but I also learned some tricks. Like setting your grid to make it easier to draw these 3D bodies. You know, stuff like that. Is that enough? Can I do that? Yep. Extruded. 2.54. Black. H row 2. H row 3. 2.54 millimeters. Black. All right. And then almost there. A couple more. I'm going to have to add... Oh, wait. These are far enough apart, actually. Okay, cool. I was worried about that. I'm going to have to make sure and add this stuff to the bill of materials, because otherwise I will forget to order it. And then that would be a shame. Something's off with these. Hang on. Pad. Minus 4.57. Okay. Is it centered on anything? That's it. H row 3. 2.54. Okay. And then these ones just go straight across like normal. H row 5. Okay, I think that's everything that I need from this. Perfect. Let's go check the 3D model. Looking good. It's got everything, all the headers in there. Sweet. That's perfect. That's exactly what we need. All right, let's go back to that. Save that. We're going to name this C1. There's external USB. Just something so that if someone finds it. All right. Save that to the server. Everything should be good. Oh no, there's errors. Cancel. Duplicate designator. So evidently, okay. There's got to be a way to turn that off then, because it was definitely done that way initially. Hold on. Here's the note on it. For a component that has already been placed, if the component pins are not locked, you can simply double click on the pin and edit the designator and the associate. Typically, the duplication will reside in the schematic symbol associated with this component. In this case, you should edit the component, modify its associated schematic symbol, and then commit the changes in the new version of that component back into the community vault. Default report mode is a warning. Is there any way I can change these? duplicate. Let's see. Trying to figure out what all of them are. Missing pin designator in sequence. 42, 43, 44, 45. Oh, but they don't exist. Yeah, okay, that's fine. Alright, so how do I fix this? Oh, there's a... Hold on. There's a pin 46. No, there's not. Oh, yeah, there is. The LED. Is that extra one? Here, we'll look at this real quick. I don't see a 46. I was worried that that's what this one was, but it doesn't look like it. I think it's talking about these in here. Hold on. Alright, so how were they able to do this before? Maybe this was a new thing that they don't allow anymore? Ugh, excuse me. I might have to go through and rename all of the grounds to like G0, G1, G2 if I can't figure out how to turn off these errors. Preferences. Oftentimes there's like settings for the errors. You can decide which things are issues and which aren't. Compiler. Just the display. That's the only thing you can change. Okay. Well, dang it. It was almost easy. So I guess, do we go through and just rename them all? Let's see. Yeah, nothing on this other than make sure you don't do it. So I guess that's kind of weird though. I also just realized that these labels up here I think are wrong. Yeah, GNG. Okay. I would think though that it would allow you to do this, that there would be a way to tell it, hey, this is intended. And also this LED thing, where is that at? Okay, so these bottom 6 are... Oh, okay, so that's where pin 46 is. It's these bottom 6 are in that Ethernet header. All right, so there's definitely something I'm missing here then. Compiler. Nope. That's what I was already looking at. All right, let's see. Ooh, may have found it interesting. Studio. Oh, this is not. Dang it! I thought I found a forum thing that. Unpin. Well, if anybody can figure this out, please let me know. Oh, yeah, if you just showed up, sorry. Basically, it's throwing an error because this device has, multiple ground pins, and if these uh, numbers out here, what are known as the designators, are the things that match the pins up to the actual like the footprint. And so it's throwing an error because some of these have the same name, because these are both ground pins, for example, and they're both named G, which should be allowed because they're internally connected, so that would make sense, right? So I'm trying to figure out a way to either turn off that error or I don't know, make it allowed, because I don't want to rename them like G0, G1, G2. But it's looking like it's going to try and force me to do that. But somehow before they've done this, so I don't know if the rules have changed in a later update or what. I agree. It's dumb. it's a it's a feature, is what it is. Uh, Anytime I click the save to server, it compiles it, and then I get these errors, which are all duplicate pad designator. So G 3V G EG. The parts carry their own rules. I don't know. I would think so. Like, because what I'm working in here is not like the full, like my project, but within this specific part. I don't know, actually. Pin 46 is the symbol. Where is this? Clearly there's something else I don't understand, because I'm actually getting a different error here. Pin 46, LED passive. I wish it would take me to these things. Okay, so there's something else I'm missing here too, which might help me figure it out, but yeah, there is a right-click menu, but it doesn't do anything. I've got compiler options here, but that just takes me to this page, which just lets me set the colors of the errors, but won't let me define it won't let me define what errors are allowed and what isn't. On the error list. That's a good idea. Let's double check. Let's just try this one. Let's probe to previous message. Clear. Copy. No. Copy. Copy. No. Yeah, it doesn't look like anything useful here. Just formatting options for the errors. All right. One of the first things I'm doing if I get a if this channel starts making a lot of money is I'm going to get a Fusion 360 subscription. It's like $500 a year, but comes with a paid CAD program and a paid PCB program all in one package, all in one suite, and easily import things, and I can define my own error rules. As well as a multitude of other nice features that come in paid programs. All right. There's something else that I'm not understanding, though, because this pin 46 isn't showing up. Let's see. It's named something different here, I think. Yep, named LED here. I wonder how he got away with this. I've copied both of these from somebody else's definition and then just modified them. I guess that this one's got to become LED. That'll fix that error. Oh, wow. There is a stampede upstairs. Oh my goodness. I don't know if y'all can hear that. Gosh, it's coming through the microphone, isn't it? I can see it on the mixer. Oh, man. Okay. On the mixer, it was shooting way up every time I heard footsteps upstairs. Like, legitimately, like, stuff on the walls is shaking. Somebody is just running around up there. All right. So let's change that one to LED. And then if I do this again, that should get rid of one error at least. It got rid of two. Okay, good start. I guess I got to go through and rename all of these things. This is so dumb. But if it's got to be done, it's got to be done. All right, is there a way to split this view? There is not. Why would there be? Yep. I agree. It's still dumb. Free software is dumb. Although they readily admit that their software is designed to make it difficult to use for large designs because it's free. So their ideal audience is hobbyists making small little things. All right. I guess I'll just work my way around. G3, G4. Okay. Looks good. And then I got to go through and do them all on the... All right. So 0 and 1 on that. I can close this preferences thing. All right, G0. And honestly, it really doesn't matter which one is which, because I'm going to connect them all anyway. But we should get them at least correct. All right, let's see. G0, G1, and then G2 is the ground on the side with no other grounds, which I think is this side. Yeah. Okay. And then coming from the bottom, G3, G4, G5 on that one. Oh, and I forgot this one. You know what? That one could just stay G because I decided it. G3, G4, G5. Oh, G3 is this one. And G5. Okay. Oh, I forgot about the 3 volts. Alright, there's only 2 of them, though. I'll just do this one on this side, make it _0. Okay. And that would be this one down here, this one. Okay, now I'm gonna commit this and nothing is gonna go wrong. Save to server. Ah! What'd I miss? Pad free, 3V. There's a 3 volt pad that I missed. Oh, yep. Fine. This one will become 3v_1. I thought it was going to be really hard, and then it looked like it was going to be really easy, and then it looked like it was going to be really annoying. Okay. That fixed everything. Probably. Hey, no errors. All right, there we go. Wow, 4.65 megabytes. This is a complicated part. I assume that means it's committed. No issues there. All right, let me take a screenshot of this so I know how it's wired up currently. And then we need to delete this. And you know what? I might be able to just position the new one in there. All right, home, part. Let's go to favorites. D4.1 headers. Yeah, let's place this. Oh, I bet I can. Since I used the same symbol. Is it actually connected though? Let's find out. Validate it. I think that means it validated. All right. Then update PCB document. Failed to match 2 of 27 components using unique identifiers. Oh, hold on. Close. We need to change some things. Hold on. U1, U2, U3. If I do U question mark, I think that'll fix it. No? Really? It's going to make me find the number? Somewhere in here I already named something. Oh, that's display. Okay, so supply 1, 2, 3. So I think U4 is free. All right, and then validate that. Looks good. All right, update PCB document. Failed to match 2 of 27 components using unique identifiers. Let's see what this does. Unmatched components in. Search for teensy and then add in all this stuff. Execute changes. Close. All right. Ooh, look. Here's our display. That's cool. And there's our teensy. That's cool too. And all these components we have so far. All right. How's the display look in 3D? Oh, that looks awesome. Look at this model. Our little LCD display. Looks so cool. It's barely bigger than the teensy. Got it from underneath. Be able to see everything. Wow, is this like a super thin board or something? Because that looks, some of these vias look tiny. I think it is. I think we'll have to set the board thickness a little more. But sweet. Those things look awesome. And then it gives connections. It doesn't give any connections to the LCD screen, but I guess we haven't set that up yet. Okay, cool. So I think it's working. I don't know what that issue was that it was talking about. Weird. Oh, you know what? Something I didn't check out. Okay, yeah, it does at least have names for everything. Alright, let's click this again and see. No difference detected. Okay, cool. Perfect. Great. Everything looks good. Okay, so next thing that we were going to do was the USB-C connector. So covering all of this so far, we've done the teensy, we've done the regulator, we've done these 4 connectors, we've done these 4 connectors, we've done the recharge circuit, we've done the voltage booster, and we've actually also added the LCD screen in here, but we haven't set up any of the connections. I want this USB-C port next, just because that's going to be on this page of the schematic, and then we'll start working through the rest of it. Ugh. I have to stretch. And there's going to be like, I know there's only so many lines here, but it's really going to come down to a lot of connections. So yeah, we'll just have to work our way through the entire list of them and then see what's left over at the end. All right, USB-C port is this Molex connector. If I am any kind of lucky at all, they will have a model for me to download, which will make this way easier. But I'm still going to have to make the footprint for it, and I just about fell off my chair. Ooh, CAD download. Now, I think that sounds like what I want. All right, here she is. Let's look at our PDF drawing. So the reason I picked this part is because everything on it is a through hole. There's no like surface mount stuff. And here's the ideal pad for it. And it even gives you the signals. All right, awesome. Man, Molex has such good data sheets. I wish everybody could follow this standard. Okay. So I'll make this footprint, and then I think I need to download this see if it'll let me download this CAD model. Oh, look at this. Look how good this model looks. Maybe it'll crash Circuit Maker when I import it because it's so complicated. I just want a step file. Oh wow, they got a lot of options too. You basically, okay, so according to their website, the way this works is you generate it. You set your settings and it generates its own. Okay, it has multiple different steps. I don't know which one to use. I guess the first one? All right. Cool. I think it's downloaded properly. Give me a sec. I'm going to open up FreeCAD and import this real quick. Well, while I'm doing that, I can go ahead and start making the part. Something else to... Okay, so let's... It probably already has it in here, just not defined. There we go. I'll get that out of the way. Yep, there it is. Is there any difference between these two? Don't think so. All right, create new component. And then footprint. Well, let's just start with the symbol, I guess. New. Okay, and then, well, this is, let's open up our model that we just downloaded. Just my luck, it won't take the thing. One has a bigger picture. Yes. Look at that. It's like the most detailed model I've ever gotten from a website before of a part. It's even got the contacts inside slightly like raised up, you know, and everything. This is a really cool look actually at how the USB-C port actually looks inside and works. Huh. Interesting stuff. All right, I think this will be fine as long as it opens in Circuit Maker. Discard that. But let's go ahead and make our symbol. Probably going to be a sizable one. Which way do pins come out? That way? All right, I'm going to do this. Rectangle. Probably don't need anything that big. Maybe like that. And then we'll center it. Okay. Let me pull a look at the drawing again. All right, this is going to be kind of weird because of our whole thing that we can't name. How's it going, Beth? Because of the whole thing that we can't have things with the same designators, but these big slots right here, I believe, need to be grounded as well because they're the outer casing, which is also metal. So So we're going to have to basically make a ground pin for each of those, and then a ground for the actual ground pins on the inside, which there's 4 of. You know what? I am going to just make this double. And then I'll work from the center and make the square smaller if I need to. One, 2, 3, 4, 5, 6. No, it missed. There's 12 pins on each side. 4, 5, 6. Because there's A1 through 12 in the first row. And then A1 through 12 in the second row. I lied. Oh, that must be fun. Be off work for 3 days. All right, hold up. It skips some numbers. It's notated A1 through 12, but it skips 2 and 3, and then 10 and 11. I wonder why that is. Okay, so there's actually 8 pins on each side. Interesting. All right, and then $180, we'll drop it right there. Oh, missed again. All right, then I'm going to drop one to space out these extra ground pin ones. There we go. All right, I think I know how I'm going to do this. Properties. So name is ground. G0. G_0. Ground. G_1. G_2. This is the fun part. If anybody has any funny stories or things they want to talk about, now's a great time. Okay, so the rest of these I'm going to notate based on this table here and their names. So I'm going to do the pin names as the designators and then the names as these inner things here. So let's go through it. So this first one is V bus, or voltage of the bus. Oh wait, no. The first one is ground. Got the outer ones are ground. And then the next one in is V bus. And let me just go ahead and do both sides. What is that? I hit something. Oh. Okay, and then the rest of these are actually specific ones. CC1. Data, oops, data positive 1. Data negative 1. SBU1. I don't know what that line is, or what the CC is. I know data positive, data negative. All right, then on the other side, we have CC2. This should be data positive 2, yep. Data negative 2. And then SBU2. So note that USB-C, you can plug it in either way and it's the same. And note how these pins are like CC1 is directly across and diagonal from CC2. And the same thing with the data lines. Data positive 1 and 2 are across from each other. All the VBus lines are diagonal from each other. The CC2 is. So basically, if you were to flip it over, your data positive is still plugged into a data positive. Your CC is still plugged into a CC. It's just the other one. And your chip, the machine talking to it, can figure that out if you put the support in there and know which one number 1 is plugged into, which one's number 2 is plugged into, and just cross the circuits. So neat stuff. All right, then we got to do all the designators. Yay. All right. A1. A4. A5. Whoops. No. Designator needs to be A5. A6. A7. A8. A9. And A12. All right, and then the other side, it actually goes up. So that's B1. Whoops. B4. B5. Six. B7. Which is a shortcut key for the properties. B8. B9 and 12. Awesome. All right, that was a lot of work, but I think we got there. Okay. Footprint time. I believe all this stuff is measured off a center, so we can probably use that to make it pretty easy. They're also specifying, okay, so notice this. In this footprint here, all these little vias are connectors right here. They're specifying that some of them are connected together already. We should be able to do that. Even in the part here, we should be able to draw connection lines. I think. All right, I'm going to do one and then copy it a bunch. And how far apart are these? 0.85. And what is the width? All right, I'm trying to figure out how to read this. The inner diameter, I believe, to be 0.4. Oh, there's two different numbers here. Sorry. I was getting confused. Okay, so real quick. This one, it's really hard to see, but this number points to the inner diameter, so it's 0.4. And the outer diameter is pointed to over here, which is 0.7. So properties. Oh, it was still in. Let's go to metric. All right, thank you. Properties. So the whole size should be 0.4. How do we do the hole in these ones? Because this is not a round hole, it's an oval or slotted. Oh, there's a slot option. Oh, that's nifty. All right, that'll take some tinkering to get right. But anyways, 0.4 millimeters there, and then wow, rounded rectangle. Wow, you can do a lot of stuff. Okay. I'm definitely going to get to tinker around with some things to get this right. And then the outer is 0.7. All right, that looks correct, probably. What's that gray part? It is multi-layer. Don't know. All right, so let's put this one in the correct spot. We know they're 0.85 apart. So do 5.95 divided by 2, according to this. 5.95 divided by 2. Negative 2.975 on the x. So negative 2.975. And then on the y, we're going to do up 0.5. Okay, that's where that one goes. And then they're all going to be very close to each other. 2, 3. I don't think I did this right because there are 4, 5. Hold on. There's not enough room for it all to fit. I don't think. So something's not right. What am I missing? Jeez. Okay, this orange part. That's the top layer. That needs to be smaller. It needs to be the same size as the hole. Jeez. More upstairs neighbor shenanigans. I don't know if there's a way to really change that. No, that's too big. That was 0.102. Yep. I don't understand what I'm looking at is the problem. I think this needs to be 0. How does that make sense, though? Hold on. Let me turn something off. Turn this multi-layer off. All right, that didn't change anything. It's not the overlay. What is this white thing? So, okay, hold on. So if I go to this, properties, negative 2.975. If I subtract 0.85, the next one is going to be negative, or is going to be 2.125, right? So let's go to that one. Negative 2.125. Enter. See, and see they're like how they're touching? That's what I'm trying to figure out is what's up with that. And I think it has to do with this solder mask expansion. I'm trying to figure out how to turn that off. Hold on. Ah, there we go. So what's this solder mask? That's the stop layer, I believe. This is what I get for not fully understanding Circuit Studio. All right, so if I change this to 0, then that should correct it. Yep. Makes it the right size. And then if we go to the 3D view, yeah, we see that there. It still looks fine. All right, I think we just do that for now. So go and delete all of these. Copy this one again. One, two, 3, 4, 5, 6, 7. The whole top row. All right. So negative 2.125. We want it to be 0.5. Okay. This next one. Negative 1.275 and 0.5. Okay. And then negative 0.425, 0.5. And then we want this one to be 0.425 and 0.5 plus 0.85. 1.275, 0.5, 2.125, 0.5, okay, and 2.975. Okay, there we go. And then I'm going to copy all of that. Copy, paste, and then I'm going to just drag it down. This is my, well, it doesn't look like it's going to work out evenly. That's a shame. I'll have to go through and notate it all, but, or fix it all. Negative 2.975 and negative 0.5. Couldn't be easy. Negative 2.125, I believe. Oh, wait. Don't do that. Yeah. All right. Negative 1.275. 0.5. I'm having fun. That's what's important here. Oops, I don't think I got that. Yep. Negative 0.5. Negative 0.5. 2.5. Negative 0.5. And then 2.975. Negative 0.5. All right, cool. The best part of all of this is that we'll be able to check our work when we import the model. All right, designators. A1, A4, A5, A6, A7, A8, A9, A12. And then other side going backwards. B1, B4, B5, B6, B7, B8, B9, B12. All right, cool. All right, so now we got to figure out how to do the weird the weird mounting points. All objects, pad. Okay. Let's see, 8.64 divided by 2, 4.32. All right, so about the only thing I can know how to do here for this one is negative 4.32 and 0. Okay. The rest of it I have no idea. Whole size shape. Okay, I guess this part makes sense. Hold on, how big is it? .2. So the y is 3.2. And the x is 1.3. Okay, closer. Just for reference again, I'm trying to make this shape right here. Corner radius. What happens if I make this 100%? Okay, that does the thing I want it to. All right, we're going to continue our manual rule of 0 here. And then we need to do the inner hole, which is going to be a slot. Or a rectangle, maybe? All right, this is going to be tricky. 2 millimeters. Let's do a slot and do 2 and see what it looks like. Nope, that wasn't it. All right, rectangle. Closer. Oh, wait, hold on. I think I know what's going on here. All right, slot. And then how big is that inner piece? 0.7? Yeah. Hey, there we go. All right, I think that's exactly what we want. The radius on that is 0.35. I'm assuming because it's a curve all the way around, that's exactly what it did. So maybe it's good. Wait. Oh, dang it. All right, I messed up the bottom row here. These should be down 0.85. This would be negative 0.85 millimeters. I'm just going to copy that. Okay, there we go. And then I think we decided from our symbol, which one was that going to be? I guess we're just picking one. Probably ground 1. No, ground 0. Yeah. G_0. Okay. All right. That looks correct, probably. So let's copy it, paste it on the other side. G1, 4.32. All right. I'm getting tired. All right, and then I got to do the smaller ones farther down. All right, hang in there. I can do this. All right, these are lined up, evidently. But how far down are they from the center? 4.15. So negative 4.32. And down 4.15. Oh, I went the wrong way. Negative. All right. So now how to do the slot part of it. Because I definitely don't know. So the outer rectangle is the same width, the 1.3, but its height's different. It's 2.5. Okay. And then the inner one is also smaller. And it's offset. I don't know if I can do that. Oh, I can offset it from the... I can offset this one. Okay, maybe that works. Okay, so it's 1.6 millimeters. We know that one's 2.5, and then how far off is it? It's 0.6 down. I think if I offset it by 0.3. negative 0.3. I think that's what it wants. Kind of. No, wait. What is this grid? Grid size is 1.27. Let's make it just 0.1. Okay. 1, 2, 3, 4, 5, 6, 7, 8. A little more. Okay, so something's wrong there. I read this diagram wrong. So I'm trying to figure out this thing right here, and I think it's this number. And it says 2 minus 0.6. I think that 2 stands for how many of the features have that. Yeah, because it's 4. Okay, so it's just negative 0. So, or the distance between these two is 0.6 millimeters. 2.5. So did I get the width of the... It doesn't look right is the problem. It doesn't look as close to the picture as I thought it would be. I had to get the 2.5 height. I guess that is right. Maybe it just looks really weird, but it is technically correct. All right. Copy, paste, move it over. So it should be 4.32 and down 4.15. Okay, and then we need to change, so G0, G1, and then I guess G2 and G3. Oops. G0, G1, this should be G2. And this one should be G3. All right, if I go to 3D view, I think all that looks good. It's odd the way it renders it, that it doesn't show it as a whole all the way through. Anyone else notice that? Very interesting. All right, now I need to somehow get this 3D body in here. 3D body. I don't know how to do this. Let's just do a basic thing all the way around. Generic. Height. I'm not sure how easy it's going to be to use. All right, hold on. Downloads. Anyone want to take a guess what it's going to look like? Okay. I can already tell you by the way the size of that thing that it's probably wrong. 3D view here. Let's go. All right, it's sticking up out of the board. We need to rotate around the X. 90? Or I guess 270. Let's start with that. And then turn it around the Z. So let's do X 270. See what that gets us. Okay. And then 3D view. All right, making progress. Okay. Let's see, let's go back to the 2D view. And then Z needs to be 180. Okay. And we got the 3D view. All right, looking good, looking on target. Oh wow, it looks like we might have not have any major positioning issues too. So look at this. The tabs are already kind of in the right spot. And as I say that, they look like they're kind of in the wrong spot, but that's cool. I guess. All right, so we need to raise it up. How much up? It's probably done from the center. So what's the thickness of it? Distance to the board. Is 1.78 maybe? Eight. Okay. I think that looks better. It's too tall. Dang it. Clearly don't understand where the reference is for the center of the model, but we are close. Weird. All right, we're almost there. What am I reading wrong about this thing? Overall height is 2.56. I don't know if, let me try something. What is the thickness of this inner piece? Because it looks like I don't understand where the origin point of this is. I might just have to manually adjust it until it looks right. Also, the slots look huge. So that's interesting. All right, I'm going to try and bring it down. 0.6. So 1.18. Okay. This is just based off of a measurement to the bottom of one of the surfaces that they might be using as the origin. All right. I think that is right. I think that was a good guess. Because it looks like, yep, oh man, I gotta figure out this navigation. But yeah, it looks like at the bottom of these things are right on where they need to be. The whole size of these slots just looks so weird though. .6, then up here, 0.9. Oh, it is. Okay, it is much, much bigger. Interesting. I wonder why they do that. Well, I'm not going to argue with their spec, so. Alright, cool. So let me zoom out of this a little bit. Try and get this semi back to normal. Ish. Good enough. And then I'm going to draw a keep outline right along all the rest of this. Line. And I want this to be in the top overlay. I want a line. And then I guess it's going to hang off the edge of the board too, so there is that part. But, hey, there you go. All right, cool. I think that's everything. So let's try and save it to the server. No, we got an error. All right, what's the error? Missing pin and designator sequence. A2, A3, A10, A11. Well, yeah, it's supposed to be. How is that a problem? All right, let's Google this. How do I make this not an error? I guess I just commit anyway. Save to server. Release. Maybe that's how they did that. With that other one with the same pin names, is that it threw it up as an error, you had no choice, but then they just reviewed it all, said it was good, and released it anyway. That might make sense, actually. Alright, let's place this part. And we're going to go to favorites. And this one, Molex. And we're going to drop this right here. Look at that. And then we need to name that one. Let's see, we've used J1 through 8 so far, so that would be J9. Okay, save that. We're going to save the whole thing to the server. Ugh. All right, I'm going to, real quick, I want to put these in the, all right, looks good. Update PCB document. Add J9 to teensy. Execute changes. Close. There it is. Look at our little connector. Go to 3D view. There he is. Neat. All right, that looks cool. Good stuff. Since I published those changes, I'm going to go ahead and sync it to the server again. Or can I? It may not let me. home, file. Nope, it won't. Okay. Assumes everything's good, I guess. All right, cool stuff. So I think that's a great stopping place for tonight. I got a lot of work done there. We still have to connect it up so that this part is still not done because we still have to connect everything together, get the right power lines connected into certain things, the data lines connected. But we're making good progress there. We'll have to make another component of sorts for a place to tie some wires in case we need to do a jumper cable. I don't think there's anything else. Yep. So once we do that, we'll have basically this USB-C and all this power stuff done and the teensy, and then we can start getting into the other things here, like the power button, the screen, all that stuff. We'll have to... I went through all of these things, and I couldn't find models made for them, so every one of these we're going to have to make a model and then wire it up, you know. So, yeah, that'll be a fun time. But anyways, thank you all for joining me tonight. I really appreciate it, and I will talk to you all some other time. I guess today's Thursday. I'll be streaming again on Tuesday, so see you then.